My name is Corey Hulse, a consultant from Thorogood Associates, and presenting alongside with me today is Jennifer Cherry, also a consultant from Thorogood Associates. We're excited that you're joining us today to discuss the possibilities of Microsoft and big data. We will now begin the recording from that day's event.
The focus of today's presentation is discussing HDInsight and Microsoft's offerings in the big data space. So let's go over our agenda topics for the day. We'll discuss big data and why it's important to the enterprise, explain active archives by exploring a case study with TNT Post. We'll highlight Microsoft's offerings in the big data space and show tactical and strategic approaches to adding Hadoop into Microsoft's BI landscape. Lastly, we'll share our real-world experiences of working with Hadoop. We appreciate that everyone on the line here might have different levels of experience with these topics, so please feel free to ask questions in the chat panel. So let's first talk about a phrase that has a lot of buzz around the industry, big data. Now, big data can mean a lot of different things to different people, but here we are showing the 3 V terms, which you may be familiar with: volume, velocity, and variety. When we talk about volume, generally we refer to huge volumes of data. What constitutes big is subjective to your organization, industry, and to the software tools being used. Velocity is referring to the speed of data generation. For example, machine data, data from scientific experiments, and social media data. And when we talk about variety, we're not just talking about traditional structured data, but also multi-structured data such as XML documents, JSON documents, audio, video, and images. In addition, we'd like to add a 4th V into the mix here, value. And so what do we mean by value? Here we have a definition of big data in plainish English. Big data is where the data volume, acquisition velocity, or data representation limits the ability to perform effective analysis using traditional relational approaches or requires the use of significant horizontal scaling for efficient processing. The value is at the intersection of the 3 V's, and the big question is whether or not you see real value in dealing with this intersection. Can you harness the data that's out there to deliver that value proposition for your organization? The primary goal of using big data is to help companies make better business decisions by enabling users to analyze huge volumes of transactional data, as well as other data sources that may be left untapped by conventional business intelligence programs. It is imperative that organizations establish a sound business case before they start planning about how they will handle big data. Like any good project, you need a plan and you need a business driver. Now I'd like to turn it over to Corey, who's going to take us through a case study. Corey?
All right, thank you very much, Jen. Hello, good morning and afternoon to everyone. Now, the topic of today's webcast is Microsoft HDInsight and Microsoft Business Intelligence offerings that they relate to big data. Now, we figured the best way to highlight the possibilities of Microsoft combined with Hadoop is to discuss the project that we undertook alongside TNT Post. Now, to give you a bit of an introduction to TNT Post, they're part of the Post NL group, and they're the 2nd largest company in the United Kingdom postal market. 10 years in operation with 1,200 employees, and they are growing fast. And last year alone, they handled 1.2 billion items of mail, and they also utilize the Microsoft Business Intelligence stack. Now, referring to Microsoft, we thought it would be good to highlight their existing architecture. Now, this schematic here might look familiar to you if your organization is also using the Microsoft Business Intelligence toolset. On the bottom layer is SQL Server Database Engine. For TNT Post, this includes a dimensionalized data warehouse and a transactional level system. And layered on top of that data is an analysis services cube, and in the presentation layer we see tools like Excel, Power Pivot, and reporting services, which are used to deliver that information from both the cube and direct from the underlying SQL database. Now, TNT Post is thinking ahead about listing out their data challenges, and when they were doing that, some patterns became clear. They're growing, and so are their data volumes. Extensive tracking of packages generates many data points which need to be captured, processed, and analyzed. So they want to establish a very clear strategy. But how can they deliver on that? They want to maintain high levels of performance and control data storage costs in the face of growing volumes of data. And if we talk about the data explosion that Jen referred to earlier, it is a reality. And if you're not facing it now, you and your organization are very likely to be facing it in the near future. Now, in fact, it's a burning topic with many of our customers and indeed the industry as a whole. So let's see the various impacts that data explosion can have on your infrastructure costs and your reporting capabilities. So here we see in the market research that the data explosion translates to costs in both time and money. Hardware and software costs go up, and you have to spend more and more to maintain it, and very quickly you lose the ability to gain rapid insights due to degraded performance. So if we look ahead and drill down a bit further to assess the impacts of data explosion in the context of structured data, what we find is that enterprise data warehousing is the fastest growing environment within any modern data-oriented enterprise organization, and hence this is where the cost and performance impacts would be the most felt. Now, TNT Post saw these trends happening internally, so the question is, what goals do we want to attain in this ever-changing marketplace and landscape? So, TNT Post's vision. What do they want? Easy, timely access to both current and historic data, a single corporate active archiving approach, reduced cost of storing business data for reporting, governed access to business data, scaling regardless of data volumes, and a future-proofing way to store and retrieve business data. And so to summarize these points here, TNT Post is experiencing and anticipating the data explosion that market analysts are reporting. They want to be able to cope with that data and still be able to utilize it in familiar tools like Excel and SSRS. So we're going to try to touch on all of these topics as we highlight the solution that Thorogood and TNT built together. So let's touch on the technology that we're all here to talk about today, and that would be HDInsight. So we use this to help TNT Post start to answer the data explosion challenge. So what are some key features of HDInsight? Well, it's 100% Apache Hadoop. It's Hadoop made accessible. HDInsight is cloud-based, and clusters and nodes can be spun up on demand. And speaking of scaling up, HDInsight is extremely valuable in tactical solutions and proof of concepts to highlight the potential value in using Hadoop. You can start small in a proof of concept and continue to use HDInsight to address growing needs as you identify practical ways to tackle big data problems. Integration with Microsoft. It's Hadoop within an Azure cloud machine and the familiarity of Windows and Windows Server. This makes integration into the Microsoft set of BI products that much simpler and can be identified as a natural extension of the Microsoft Business Intelligence set. And finally, accessible to users. We're going to show in a demonstration in a few minutes here that HDInsight enables Hadoop front-end connectivity for the business and for your users. Now let's flip back to TNT Post and talk about a practical business application where we can use HDInsight. For TNT Post, it was in the creation of an active archive. So let's touch on the need to have timely access to both current and historic data, a challenge that many of you with very large data warehouses may be experiencing. So the first step of any data storage strategy pivots around data usage analysis, and so we're going to refer to terms here, hot data and cold data. Now, hot data, on the right in red, is what's current, frequently accessed, high degrees of change. Now, cold data is on the opposite side of the spectrum, infrequently accessed, rarely changing. Now, if you've had a data warehouse that's been in operation for quite a few years, it's reasonable to assume that it holds lots of cold data. So what can we do about this cold data? Data that is negatively impacting the cost of storage and reporting performance. So an effective solution, let's archive the data. But does your current way of archiving work? Is it effective in lowering the burden on your enterprise data warehouse substantially? The likelihood answer is no. The first reason, of course, being existing archival methods. Usually these come in the form of tapes and backups, which are always offline, not directly accessible, and have a delay in restoration. If you need an answer now, you're going to have to wait. The second reason is it's extremely difficult to define relative value of data across any business process. For example, without understanding the true relative value of any given data set, most IT managers and business users just try to keep as much data as possible in their existing data warehouse and only agree to ever archive data which they might consider to be junk or not as useful anymore. So this simply means that the current archival strategies are not quite effective in reducing the burden on the enterprise warehouse as much as they should, which means increased costs in both storage and maintenance. So what could be the solution? How do we improve on this? How can we implement an effective archival solution which will help reduce the burden on enterprise data warehouse costs substantially? And we think that answer lies in an active archiving approach. So the idea behind the active archive is to take data and as you move across time, stripe it out and move it into a proper archive. So how you define this and achieve this is dependent on your business goals and needs. And so you could define thresholds configurable per system or even down to individual tables. Dimensional and transactional data can be combined in an archive so there's a consistent and complete set of data to report on, both operationally and in the archive databases. Now, overall, it's one place to store any piece of information. Collect once, use many places. But there are many considerations to make depending on your organization. How do you handle data access and governance? How do you handle and maintain costs to achieve database growth? So how you answer these questions all depends on your organization strategy. Now, you might be saying, now hold on, wait a second, aren't you just suggesting that we take data in one database and shift it into a second database? How does that reduce data storage costs? And the premise behind that is to use Hadoop. And we can take advantage of Hadoop by keeping your existing hot data store as SQL Server and put cold data into a Hadoop cluster. So more about Hadoop, for those who may not be familiar, we have a very brief Hadoop 101 introduction here. Hadoop is a framework and a platform which is comprised of two key components. It's a Hadoop distributed file system and MapReduce. Now, together they provide Hadoop the power and ability to parallel process prestigious amounts of data, plus give us the ability to interface Hadoop with the tools in your organization that people already know and love, like Excel, like SSRS. So what are some of the key features of Hadoop and why we think it's important? Low-cost data storage, and this is because of two reasons. Hadoop does not need high-specification servers to run. Instead, servers with average computing power are good enough to be used in a Hadoop cluster. The cost of such a commodity server could be somewhere between $800 to $1,000. And at its core Hadoop is open source and hence does not attract any licensing costs. Hadoop is highly scalable. Just referring to some other big players in the industry out there, Yahoo has 42,000 nodes, and this was as of 2011. And the last time we checked, Facebook had over 10,000 Hadoop nodes in their cluster. And it's got batch-oriented processing, so this is great for high-throughput tasks, for example, ETL of billions of rows of data, but not so great for low-latency tasks, for example, business intelligence and analytic queries. So there's a potential challenge here, and the question is, how can we address that to make Hadoop effective in the enterprise space? And lastly, Hadoop allows for data variety, so structured traditional data warehouses, semi-structured data, such as social media data, and then unstructured data, things like machine data, audio, video files, pictures. So if we were to summarize, what are the three big things about Hadoop? It radically reduces the cost of storing data, it radically changes how much can be stored, and it can store data with structure or without structure. This is going to open up a lot of opportunities for any enterprise organization. And when we say radical cost savings, we really do mean it. It costs about $20,000 to $40,000 to store a terabyte in a traditional data warehouse, and because of this reason only, the majority of the impact of the information explosion will be seen in spiraling storage and licensing costs. Compare that with Hadoop, and you can see that there's a definite cost savings to be had if you can build a data strategy which allows some of the enterprise warehouse data to be offloaded to cheaper Hadoop storage. So let's say we can accomplish this. SQL Server as our traditional data warehouse, and Hadoop as our archive. Now, first of all, two separate databases. How can we prove that this can work? How do we bridge the gap? And the answer to that is HDInsight. HDInsight can be the bridge that connects the two and enable your organization to be prepared for data growth. So why HDInsight? Why is this the solution? Well, it's a pre-configured Hadoop cluster using Windows Azure, and it's a service in the cloud. So what does that translate to? You can get started quickly without significant hardware investment, and HDInsight allows you to grow and change as you adapt to tackle business challenges in this new big data world. So really, if you think about it, HDInsight really does sit in the middle of the spectrum between an academically deployed Hadoop on commodity hardware and, on the opposite side, expensive enterprise data warehouse appliances. So we hope this shows you that there are a number of compelling reasons why it could be a good selection for your organization, especially if you're considering Hadoop. So let's spin it back to TNT Post here. Let's remind ourselves of that existing architecture that we have there. And you can see Microsoft focused through and through. So we're going to bring HDInsight into the mix for our proof of concept. You'll notice that the front-end tools are staying the same, and we're going to show a demonstration of some of those front-end tools soon. Now what's different is the integration of Hadoop using an HDInsight machine as the platform of communication between your traditional data warehouse and SQL Server and the Hadoop cluster. Now for our dimensionalized OLAP data warehouse and analysis services, we've partitioned the data to reflect the active archive, where recent data is being sourced from SQL Server and older data is now being accessed from Hadoop. We also had a transactional system in play here, and we even enabled direct access to Hadoop to allow data tools like Power Pivot or reporting services to get line-level information which may not be otherwise available in a dimensionally stored cube. So what does this mean? Results in savings in storage and still allows data to be accessible to users. So we've been chatting a lot here. We'd like to show some demonstrations now, and let's go ahead and take a look at what some examples might look like from an end user perspective. And three things that we're going to be showing here: an analysis services cube that's sourced with Hadoop data. We're going to show some more formal reporting with reporting services, and we're going to highlight a Power Pivot model which is sourced from Hadoop. So if you give me a moment here, I'm going to share my screen with you. And then we'll start on the desktop here, and I will bring up an Excel sheet. So in this Excel sheet, we've connected to an analysis services cube. And the analysis services cube, you can see in our sales count table here, has about 100 million rows of data. We're at 92 million rows of data. And so this might be typical of cubes and data that you have within your own organization. But what we're going to do is spin out some information here. So let me remove the store count and take that off. And then what I'm going to do is bring on some of these dimensions here. So let's move the year down, and we can show you how much data we're actually sourcing from this cube. So we've got data going all the way back to 1993, and we see our store sales amount split out across that time. That's pretty cool. We have a lot of data available in this cube. And leaving this all in a traditional data warehouse might end up slowing it down, not give you the sort of speed and insight that you're used to, especially for this older set of data, which probably isn't going to be changing anytime soon. So now I'm going to bring down the source onto my rows. Actually, let's spin that back up here. Might be easier actually if I throw it into columns and we can see the difference here. So what's happening in the cube is that the cube is actually partitioned out and pointed to two different sources. All of my older years, from 1993 all the way to 2010, are actually coming from Hadoop. I've processed it, I have the data available to me, but that data is actually being stored in Hadoop. On the SQL Server side, I have the recent data, and that's data from 2014 to 2011. Now, at the end of this year, we'll have an archival process that moves 2011 over to Hadoop, and it's a very simplistic way of trying to achieve cost savings by storing the majority of my data in commoditized servers using HDInsight. So we've got that here, and we want to show this chart view here because we feel it reflects the cold data, hot data storage slide that we showed earlier. Thank you, Excel, for matching up the colors appropriately. So we've got the recent hot data coming from SQL Server located over on the right. The data that was actually sourced from Hadoop, the cold storage data, is located over on the left. But instead of being on tapes where I can't access it, it's available to me and available for my users to start to gain insight from. And so we can interact with this data just like we would any other table, irregardless of the source that it ended up coming from. So I'm going to take source, we'll put that back on here, because to my end user, it doesn't matter where that data is coming from. And now I can interact with it just like I do any other cube. So I can bring product information down here. We can start to expand out to various different levels. So we'll expand the entire field, and we'll get down to categories and subcategories. And then it becomes just like any other pivot table that you might be used to. except part of the data is coming from Hadoop, part of the data is coming from SQL Server. And then we can, of course, build visualizations off that and see those breakdowns. But the idea behind this is to put everything together in a nice interactive sales dashboard. And what this allows us to do is see all of the data available to us for that year. So I've created just a very basic interactive Excel sheet that has pivot tables that are driving it, but I've included what you may find in newer versions of Excel, and those would be slicers. Data that's sourced from my source data set. So if I just wanted to focus on a single year, I can click on that and my data will change appropriately. Oh, that's interesting. Let's see if we can find any trends for recent years. And I can now go and select years. So some of that data has actually come from Hadoop, some of the data has come from SQL Server, but it doesn't matter to the end user because I've unified it using an analysis services cube. I could do specific focus on individual category names too and have all of my charts reflect appropriately. So if we wanted to focus in, okay, hey, we're seeing a big peak in cameras and camcorders, maybe I should select on that and we could see my data change and I can see my top performing subcategories. So an interesting business application for, we have 92 million records in here, about 4/5 of them were actually originally sourced from Hadoop, all together in a single cube now, which allows me to have good business level interaction. So we showed you Excel, and now we're going to flip over to reporting services. So we're going to open up, I've got a local instance of reporting services here, and just show you some more highly formatted reporting, again with data being sourced from SQL and also from Hadoop. So I'm going to go into my data source here. So we have a Power Pivot model, and for those who may not be familiar with Power Pivot, what Power Pivot is it allows you, instead of just connecting up to a single instance, what it allows you to do is combine sources that come from various different disparate data sources. And so I'm showing the Power Pivot model that we have here, and I'll show you the connections that we have here. So what we have is a query, and what I've done is predefined this query to come in directly from Hadoop. So instead of feeding it through the cube and coming out via the cube, I'm going directly against Hadoop through this query that I've defined here. And it's a very simple select query that we have from our fact statement, but the business case behind this is, let's say I'm an individual promotions manager, and as the promotions manager, I'm interested in just a subset of data, but I'd really be interested in individual transaction lines that are related to my promotions. So I can define a query that comes directly from Hadoop, but then I can connect up my various different dimensional tables, and those could be sourced from elsewhere, and in this case we're using SQL Server. And so the two of these come together, and it allows us to do that. So I'm going to hit refresh. This will probably take a few minutes to come back, but in the meantime, let's show you what that resulting set looks like. So I've connected it up, and let's go to the data view. And what I did earlier today was I did an extract directly from my Hadoop table, and we retrieved about 3 million rows direct from my Hadoop set. And in that set, I've gotten my data to connect up to all of the dimensions that I need to. So I've defined a very basic data model, and now let's create a pivot table with that set. And what I've done is I've taken an extract of that information, and that is coming in through my model now, and I have it stored locally in an Excel sheet. So here are my 2 million rows that are coming in, and I want to see my sales amount. So I can build out a pivot table, but this is all sourced from a local Excel sheet, which is now being stored in memory. And so I can bring on some of the same types of data that I saw by interacting directly with the cube, but now I can take this offline and I can take it with me, and it's an extract that I've specifically defined, which is sourced partially from Hadoop, partially from SQL Server. So at this point, let's see if my report managers come back. All right, looks like our reporting services instance is back on. So let's take a look at some more formalized reporting that we have here. So I've clicked on that, and we're sourcing that data from the cube to build this SSRS report. And so for those who are familiar with SSRS, we're using native mode here. We're making some very basic selections, and I'm going to select everything. I'm going to select all 92 million rows and have that data come back pretty quickly summarized from the cube. So this is summarized across all of my calendar years, and I have a breakdown by category. So for your users, you can still give them a very formalized experience. Let them go on their own and create Power Pivot models, give them a formalized cube or formalized SSRS reports that they can do their reporting off of. But underneath this all is data that ended up being sourced from two different places, partially from Hadoop, partially from SQL Server. So there is one or two more reports that we want to show here. The first one, I'm actually going to show a transaction details report. And this one's really interesting because we're not feeding it through the cube, we're taking it from Hadoop directly. So even in something like SSRS, which is more formalized reporting, we can directly connect to Hadoop and get transaction level details. So let's see what transactions we've sold in the system today. So I can go and pick on a date, and then it's got my appropriate parameters. I'm going to view that report. This will take a few minutes to come back. And again, we talked about some of the challenges earlier. Hadoop is not completely optimized for instant BI reporting. There are many optimizations that can be done in terms of how you structure that data in Hadoop, what are compression algorithms that you can run on Hadoop, and we have much more information that we can share about our experiences so far when it comes to that compression. So we're going to let this run in the background for another minute or two. In the meantime, we're going to switch to this profit margin report. And what this allows us, again, going back against the cube, I'm going to select all continents, and we're going to select all the years, and I'm going to view the report, and we can get some visual analysis here. So we saw visual analysis coming through in terms of putting things into an Excel pivot table, but here's more formalized reporting that we're using in SSRS to give us visual analysis of data that's spanning many, many years that happens to come from different data sources. So if we look here, interesting, maybe there's a trend happening here. Is it related to the marketplace? What is it related to? What are my poor performing categories that I have low profit margin on? Is there more insight that I need to do to dig into that? Let's focus in specifically on North America, and let's make a date selection that's actually going to span between the two sources. So again, partially from SQL Server, partially from Hadoop. So what we can see here is even though the data ended up coming from two different sources, we're merging it together and spanning it here, and we can see some trends hopefully show up. We could see that we seem to have taken a big hit during the global recession in terms of profit margin that we were selling on our products. We had a lot on our shelf. We had to offload a number of things quickly. But what this allows us is insight into, well, TV and video. Where's the margin? We were making good margin a number of years ago. There was an uptick last year, but that uptick didn't seem to happen on TV and video. I'm getting insight now, and that insight can help me dig into the future data and the past data to perhaps take action specifically related to TV and video to see what's next, what are business improvements that we can make. All enabling business users to go about their business, help make better decisions while spanning data that comes across many, many years. So let's see if our report's back yet. So our transaction detail report isn't back yet, and again, I mentioned that this would take a few minutes to come back. But we've reached the end of the demo here, so we're going to, it's like a cooking show where you pull the prepared one out of the oven already. So I want to show you what that looks like from a finished perspective. So I did run this one a few minutes before the actual event. So this is showing our transaction details. And so we pulled about 9,200 records directly from Hadoop. And when I ran it last night, it took about 4.5 minutes to get that information. And we'll have some more slides on performance in a few minutes here. So what is this great for? To get directly to Hadoop, to get to transaction level detail, I can put a date in here all the way back in 1993 and within 3 or 4 minutes have transaction details from sales that happened that long ago show up. Compare that to having an archive where it's not available, where you have to restore tape, where you may not have this information anymore. You could still keep this information present and at people's fingertips. And it seems like I've stalled long enough where the actual report that we just ran has come back now. So we could say, all right, so today we've done about 10,000 transactions in sales, and I can see my individual line-level transactions. We did something very simple here where we just had a date selection, but let's say you wanted more robust selections. Okay, show me all my products across all time that have been sold to this specific customer. We can design a report that does that and smartly dynamically builds the query needed directly against Hadoop to properly populate what it is that you need, whether it's through formalized reporting in SSRS or through more ad hoc we're confusing terms here, power pivot style, where we're putting together an interesting spreadsheet which is sourced from many different sources. So what have we shown here? Well, we've shown you some interesting front-end analytics that come with using HDInsight to merge together two different data sources, Hadoop and SQL Server. We saw an analysis services queue that had Hadoop data in it, formalized reporting through reporting services, not only against our existing cube, but directly against Hadoop. And we have a power pivot model, which we source data from Hadoop. So let's dig in a bit more about performance. What we saw with TNT Post specifically during their proof of concept, we're referring to queries coming directly out of Hadoop. So in that demo we just saw, it took about 4.5, 5 minutes to come back for a small query. We haven't done any optimization. We spun up an HDInsight server a week and a half ago, and we built this demo from scratch for you for here today. And so there's many optimizations and performance tuning that we can do to both the Hadoop and the SQL side to get things running better. So for TNT Post, you'll notice that the high amount of overhead comes when there are very small queries. However, there's definite power in numbers and the parallel nature of Hadoop. When you go from just 1 million rows to 20 million rows in a query, you get a 20 times increase in results, but only double the query time. So again, compare this to existing archiving methods that involve tapes and restoration of backups, whereas not having that data available at all. So HDInsight, what did TNT Post see as benefits coming out of their proof of concept? Well, seamless for users. The front-end tools are staying the same, and indeed, it can unlock more possibilities by having more data available to your users' fingertips. Cost savings. We showed you some graphs that showed cost savings with Hadoop versus a traditional data warehouse. And then HDInsight specifically, it enables proof of value and quick growth. Spin up a machine like we did, connect it to some of your existing data sets, and show the possibilities within your organization. But really, it's about optimizing your data storage strategy. And we just showed a very simple example where we moved a few years of fact data into a table in Hadoop. Now, in fact, proper strategic initiatives should absolutely be undertaken to find that optimal balance within your organization, and Thorogood can help with that. Talk to us about what should your strategy be moving forward. So TNT Post is also getting ready for whatever the next big thing is. Can they take advantage of market data, social media data, other data streams which otherwise have been left untapped because of previous limitations? They are future-proofing themselves to be ready for whatever comes next. So we've been talking a lot about tactical strategies, how do you get started, spin a machine up, do a proof of concept, but now we want to move on to think a bit more strategic and where Microsoft can fit in. So let's say we've proven the value. Hadoop looks great in a proof of concept, but where do you go from here? So TNT Post faces that same decision, and here we have mapped out some possible next steps. Well, they could do nothing, but that would seem foolish in the light of the imminent big data explosion. They could have a decentralized strategy, and the individual groups or departments figure out what's best for them, or they could centralize their archiving process in an existing traditional data warehouse, or centralize the process and make the move up to Hadoop. So we've laid things out, and what this chart represents is a cost ratio analysis of some of those options for TNT Post moving forward. We haven't even included the idea of not doing anything because you need to do something in this changing world. But by decentralizing your archiving, and that's represented by the gray line, which spins up pretty quickly, you might be saving money in the short term, but you're losing the opportunity to gain economies of scale by centralizing the process through rigorous approach to archiving data and having a big data strategy. Now, you could centralize and use the existing EDW structure, which you might already have in place. And that might seem less painful in the beginning because you already have servers and licensing, but the cost of data storage is going to continue to rise, and we think exponentially, as the data explosion continues. Now, with Hadoop, and that's represented by the yellow line on the screen here, there's definitely more of an upfront cost in terms of strategy and setup, and we figure that's about a 2-to-1 ratio in terms of expected initial costs. However, the benefit is future-proofing yourself against the wave of data that is inevitable in this day and age. You'll also set yourself up for success as new opportunities and new data streams come online to quickly react and integrate those into your business decision-making process. You'll be ready. So HDInsight is a fantastic appliance for driving future growth with big data and Microsoft. Now, what does the horizon look like beyond HDInsight? So here, we wanted to introduce the Analytic Platform System, or APS for short. What is APS? So it's a single Microsoft turnkey appliance that integrates SQL Server, Parallel Data Warehouse, and Hadoop. And we have more to share on this in the next slide. What are some of the benefits of the APS setup? So scaling up. You can move up to 6 petabytes of space, which gives you plenty of room for growth. And as we mentioned before, an integrated appliance that combines Hadoop with SQL Server Parallel Data Warehouse, and we'll show a demo of this in a few moments. But really, the benefit comes from Polybase. And what Polybase allows you to do is use the familiarity of Microsoft T-SQL to unify queries that span different architectures. You're familiar with T-SQL. You can use T-SQL to hit not only SQL databases, but Hadoop databases. And really, it's engineered for optimal value. We talked about some of the cost implications earlier. What APS allows is a choice of hardware. You get cost per terabyte savings and a reduced data center footprint, which can be augmented to take advantage of cloud-based services like Azure. So let's take a step and see how this would integrate into a business intelligence setup. Here we have a more generic version of a business intelligence setup. And so a few things of note. We have our front-end tools here, reporting services, Power Pivot, Excel. We've also included SharePoint because it's such a vital piece that many enterprise organizations can benefit from if you're not using it already. In addition, we've taken the middle layer, and instead of just talking about cubes, we're referring to a more generic BI semantic layer, or a BISM, which is an optimized data layer which allows your front-end users to gain business insights quickly and efficiently. So ROLAP, MOLAP, tabular, we're optimizing that middle data layer for performance and for better usability when it comes to your front-end applications. So let's say we're going to put in an APS appliance and you want to have SQL Server and Hadoop. By implementing an APS architecture, you can unify the two through an APS appliance. Your archives and data sets can move back and forth in an optimized way, and when it comes time to access and query the data, the Polybase platform utilizes standard T-SQL to retrieve the data regardless of the source. So, well, what does this mean? For your business users, it's once again a seamless integration. They get the robust experience of Microsoft front-end tools, and it's an enterprise-focused configuration with the familiarity of Microsoft backed by both SQL Server and Hadoop. So we're currently engaged with Microsoft, who have given us access into an APS environment, and so we previously recorded it. We've recorded the demonstration of an analysis services database which has 1 billion records in it. In addition, we want to show you Polybase in action, and that's what the video will show. So I'm going to play the video in the WebEx console, and I'll provide some narration as we play the video here. All right, so what we've done here is we've logged into a virtual machine. We've accessed a local installation of SQL Server. Now, within this database, we're accessing tables which are actually being sourced from 2 different databases. One is sourced from SQL Server Parallel Data Warehouse, and the other is coming from a Hadoop machine. And so what you'll see here is we're accessing, and I'm showing you the data that's coming from traditional SQL Server. And we're expanding, and you can see very familiar fact and dimension tables that might be part of any traditional data warehouse. But what we've opened up here is the external tables, and these are tables which are actually being sourced from Hadoop. So I have a customer table, which is being sourced underneath from Hadoop. Now, we're going to expand to the column members here. You'll notice that the layout is very similar to any traditional SQL table. This allows us to have consistency and to properly integrate SQL queries with queries that are actually being sourced from Hadoop. So what we're going to do next here is we're going to open up a new query, and I'm just going to do something very basic here, but we're going to be using T-SQL to query Hadoop. So we're going to do a very basic query here, a top 100 from our table, and then when we hit execute, what we'll find is that in about 2 seconds, we establish the connection, and we've come back from data from Hadoop. Now, let's see what happens. We're going to change it to do a select star and select everything from that table. And then, well, we've warmed up the cache a bit here. It took about 1 second to return 18,000 rows from Hadoop, but we're feeding it in through SQL Server. Now, we're going to see what happens when we combine two tables from two different sources together through a join. We're going to take the customer dimension from Hadoop and join it up in a fact query in SQL, but again, we're using T-SQL to perform this join. When we execute, this is just a very basic look on how we've connected up two tables from a very clean SQL interface, but really the data underneath is from two different data sources. So now I've moved on, and what we're doing is a quick look at the Hadoop side of things, for those who may not be familiar. We're selecting the database, and we're going to dig into our customer source, which is coming from the Hadoop side. So this is a source that we've just connected through in that nice clean SQL demo that we did to return data. And what this shows is that through T-SQL, we can make it very easy for front-end applications to tap into Hadoop. So we saw the earlier demonstration, and we looked at an analysis services cube, and we had about 100 million records in it. What you'll be able to see on the screen if you look on the left there is that we have a fact table that has 1 billion records in it. In addition, the cube is built in rollout mode, which is on top of SQL Server Parallel Data Warehouse, and it gives us more power to get to the data we need faster. The data structures are very similar to what we looked at in the last demonstration. We've got years, we've got some interactivity that we're doing, and then we've got sales count and sales amount. So we're bringing some of those dimension members on, and you can see how quickly it's querying the cube, not only from a pivot table point of view, but from a pivot chart point of view. So we're highlighting just some of the visual capabilities, pivot charts in Excel. The Excel's a native environment that people know and love, so by enabling something like APS and Parallel Data Warehouse, we're putting 1 billion records in the hands of the users pretty simply and pretty easily. 1 billion rows summarized in a very nice, clean, simple chart. So finally, I want to show you what it looks like when it comes together. Again, this is a dashboard type interface where we have slicers. We're using a different color scheme here than we did in the other demo. But the idea behind this one is that we've got continents and regions and countries. Again, you're allowing your users access to 1 billion rows of data set up in a rollup format, and it's hitting all of the tables respectively. And so, what do we see here? 1 billion rows of data at your fingertips because of something like APS. So let's flip back to the slides here, and actually at this point I'm going to be handing back over to Jen, and Jen's going to take us out with some conclusion slides.
Thanks, Corey. We hope that we showed you some insight today into the possibilities of big data with Microsoft. We only covered active archives today, but we've listed here some value propositions that you might want to consider for your organization, including active archives, unstructured data storage, and social media. With HDInsight, Analytics Platform System, or APS, and Azure, there are a world of possibilities for your business with Microsoft. If you're in need of Hadoop or Microsoft expertise, we'd be happy to discuss how we can help. Thorogood provides a gamut of end-to-end business intelligence and analytics services. We can help you get started with Hadoop and HDInsight, perhaps as a proof of concept. We can evaluate how Hadoop would fit with your existing BI architecture and help you explore the possibilities with Microsoft. Engage with Thorogood and let's work together to unlock the possibilities of these technologies for your organization. And lastly, we'd like to thank you for joining today. Here is a schedule of our upcoming events. We have a number of events coming up, including a Business Intelligence and Analytics update in the UK on October 16th, and we'll soon be publishing our schedule of US workshops. You can register for these free events on our website listed here at thorogood.com/events.